Hello guys, welcome to the software engineering channel. I know it's been a moment. This quarter has been a very busy one. So I stumbled on a particular post on Twitter's engineering blog trying to explain in details how Twitter composes users' timeline. So understand what the problem is here. We're trying to understand how Twitter is able to compose your For You section or your own timeline, if you will, picking out of over 500 million tweets that is currently sitting on Twitter's database and making sure that your timeline is personalized and relevant to you. And this is done for over 396 million users. That's a lot. So I had to go down the lane, starting from when Twitter started to use MySQL database queries, down to where they started to use Fanout process, and down to till date where they start to use home mixers. In today's video, I'm going to be walking you through how Twitter has been able to compose users' timeline from inception down to date. How about we dive right in, guys? So at the very core, the idea behind Twitter is to be able to share user-generated content across all of their followers, right? So as you might have guessed, as every little project to start, Twitter actually started by heavily depending on relational database, where we have things like the user table, we have things like follower table, and we have tweets table. So when a single timeline request hits Twitter's API, what it basically does is to perform a join query on all of this table to first do a lookup on the people that you follow and try to get all of the recent tweets they make. So all of this stack of tweets is what is then pushed back to your device, and obviously this became a problem as Twitter began to grow exponentially. Fast forward to 2013, Twitter noticed a particular important metric. 300,000 query per second were actually spent reading timelines, while just 6,000 query per second was actually spent writing tweets. So it therefore makes sense for Twitter to actually recompose users' timeline when this writing action is being done. That was the light bulb moment for Twitter. Hence the Fanout process, and that's actually what the Fanout process approach is. So let's say, for example, I posted a tweet. Immediately this tweet hits Twitter's write API, and immediately as well the Fanout process actually begins. So your tweet is actually persisted on a Redis cluster, an in-memory Redis cluster, on 3 different machines. And the reason why this is done is to actually ensure high availability. So even if your tweet is lost in this particular Redis cluster due to, say, the failure of that particular instance, Twitter is still able to fetch your tweet from other instance of this Redis cluster, right? So a Fanout daemon actually queries Twitter's social graph service. And this social graph service is called Flock. Flock sits on a database called Flock database. It's basically a distributed graph database that helps Twitter to maintain a particular user and the list of all of the users that follows that particular user. It's called the followings list. Right. So with this, the Fanout daemon is trying to extract all of the users that actually follows me from this social graph service. Now, having gotten this information, since all of this user has a native list on this Redis cluster, so all of these users would have something of this nature, say UID and tweet ID. Let's say that's for user 1, user 2, User 2 is also going to have its own list, UID, tweet ID. User 3 is also going to have its own list, UID, TID. All right. And let's say we have this till user 100. And let's say I have just 100 users following me. So they are all going to have this particular list, native list within this Redis cluster. So what the Fanout daemon is then going to do is to iterate through all of these users lists and insert my tweet into the list. So say for example, my tweet has been persisted maybe in the database and an ID has been generated for my tweets. Let's say the ID is 150 and this is my tweet ID, and let's say my user ID is 45, right? So what the Fanout daemon is then going to do is to insert this 45 and my tweet ID 150 into all of these user ID lists, user native lists rather. And obviously note that every other tweet of every other user that each of these user follows is also going to be inserted into this native list accordingly, just the way this is happening. And all of these are saved in memory. The reason why it's obviously saved in memory is so that Twitter is able to pull out all of this information at constant time. Of course, you know, your in-memory can be looked up at constant time, given that it has a particular key. And obviously, the key for this list is going to be the unique user ID. So Twitter actually placed a cap on how long this list can grow. So basically, all of this list cannot grow past 800 entries. Right? All of this list cannot grow past 800 entries. And obviously, this is a business decision because Twitter wants to be able to accommodate this list for millions of users, right? Millions of active users. So it is better for them to have that cap than to have users not being accommodated within the Redis cluster. And obviously, this has its own trade-off, right? What it means is if you scroll through your Twitter application for so long, you would at some point hit the 800 cap. And what Twitter is going to try to do at that point is to try to reconstruct your home timeline. So you might see a little bit of loading sign, and that's Twitter trying to reconstruct your home timeline because you have hit the 800 cap. So basically, once you as a user get on your phone and you get to Twitter home, either on your application or on the web, what this is going to do is to hit Twitter's timeline service. And the timeline service is basically going to try to pull your pre-computed timeline within this native list Redis cluster. And obviously, because it has a key, which is your user ID, the key is your user ID, it can look up your timeline in constant time, right? Hence the reason why it is really very fast. It is insanely fast to get your timeline loaded. And this is how Fanout actually works. And trust me, it's a very great idea. So Twitter is going to trade off having to do a lot of processing at the background when a Twitter makes a tweet while making the timeline service pulling of users timeline insanely fast. This gets a little bit tricky though for celebrities that has over 32 million followers, 100 million followers. Of course, so you want to imagine how Twitter is going to do this for 32 million users. So at that point they knew executing the fan out process for celebrities does not make any sense. It does not make any sense. So this process is not being executed for celebrities. Fan out process is not being executed for celebrities. For celebrities, Twitter discovered that it is easy for them to basically just do the normal query for celebrities tweets and then append this query into your list as it goes to your timeline, right? Instead of doing the fan out process for celebrities. So it's more like an hybrid structure, right? It's more like an hybrid structure for normal users who do not have a lot of followers. When you make a tweet, the fan out process begins. But for celebrities that has over 100 million users, followers, Twitter does not do the fan out process. It does the normal MySQL join query process. So it's more like an hybrid structure. So this is the way the fan out process actually works. So that's how Twitter actually ran for a couple of years. And zooming into 2023, the service currently responsible for constructing your For You section or your home timeline, if you will, is called the Home Mixer. Let's see how that works. The Home Mixer actually contains a number of components, but we're going to examine the key components of the Home Mixer and roughly examine them in order by which they are being called during a single timeline request. So the very first process is retrieving candidates from candidate source. Candidates are basically a stack of tweets that has the high chance of making it to your home timeline, while candidate sources are different components saddled with the responsibility of actually extracting these candidates, which are those tweets that has the high chance or probability of making it to your timeline. So two of those candidate sources that sit under the Home Mixer is called the in-network source and the out-network source. Although this metric varies from user to user, but on an average, your timeline should consist of 50% tweets from your in-network, which is basically the network of people you follow, and 50% tweets from your out network, which are people you don't follow. So an average person follows a large number of people on Twitter. So the responsibility of the in-network source is to actually source out candidates, which are of course tweets, as I've previously mentioned, candidates that are relevant to you, the most useful candidates that are relevant to you. When I say candidates, just substitute it for tweets, right? The most useful tweets amidst all of these people that you follow. In-network source would try to fetch out the most useful tweets amidst all of these followers of yours, and this is achieved by using a component called Real Graph. Real Graph is basically a model that predicts the likelihood of engagement between two users. So the higher the Real Graph score between you and the author of a particular tweet, the more their tweet is able to make it to your timeline. That's the way it works. So Real Graph is actually a replacement for the fan out process. Fan out process lasted for about 12 years. The Real Graph model is currently what Twitter uses to provide in-network tweets. So the second candidate source, which is actually the interesting one, is the out-network source. So the idea here is Twitter wants to be able to use this out-networking source to pull out a handful of tweets from users you do not follow. Now this gets a little bit more trickier, because how can you tell if a certain tweet will be relevant to you if you do not follow that person? Twitter approaches this problem using two different concepts. The first is social graph. So this source tries to traverse the graph of engagement, and as it traverses this graph of engagement, it tries to answer two questions. The first question is, what tweets did the people you follow recently engage with? And the second is, who likes similar tweets to you, and what else have they recently liked? This is heavily dependent on graph processing, right? So Twitter has to find a way to be able to efficiently traverse the graph. Hence, Twitter had to create their own graph engine called GraphJet. GraphJet is basically a graph engine that maintains a real-time interaction graph between users and tweets in order to be able to execute such traversal as this. The second approach Twitter used to solve this out network problem is by using embedding spaces. The question embedding spaces tries to answer is a little bit more broad and general. So it is, what tweets and users have similar interests to you, right? What tweets and users are similar to your interests? It does this in a little bit of mathematical way, takes a mathematical approach. So what it does is it tries to generate some sort of numerical representation of your interests and your tweet content. It then tries to compare this numerical representation to other users' numerical representation. It also goes as far as checking communities, right? It uses a system called SimCluster to discover communities anchored by a cluster of influential users. And it uses a particular algorithm called custom metrics factorization algorithm. Yeah, that's a mouthful, right? So it also picks tweets from these communities that you follow. If you're in a particular community, there is every probability that the tweets within that community is going to be relevant to you. So it uses this as well. At the end of the day, both the in-network and the out-network is going to produce about plus or minus 1,500 candidates, which is basically 1,500. All of these candidates is then passed into a component called the heavy ranker to perform ranking. The heavy ranker achieves this ranking by using a neural network that has been trained by Twitter using over 48 million parameters, and it's been constantly trained on tweet interaction to be able to understand what positive engagement actually looks like. So this ranker is able to rank this 1,500 tweets just so to be able to pull the ones that are actually very useful and relevant to you. After this ranking stage, Twitter then applies heuristics and filter to be able to implement various product features like auto diversity. It means this particular feature tries to avoid the occurrence of a particular author occurring consecutively. You should not see a particular user's tweet occurring consecutively on your timeline. That's going to be odd. So that's what auto diversity product does. It also have visibility filtering. It tries to filter the tweets based on your preference. It removes tweets from the people you've blocked, from the users you've blocked, and all of this kind of stuff. And lastly, the home mixer actually gets all of these tweets and then blend these tweets with non-tweet content like ads, follow, recommendation, and the likes. Blends all of this together and sends it down to your device. That's actually how Twitter currently is able to construct your own timeline using the home mixer. So I hope you learned a lot from this walkthrough. I intend to do this for more viral systems. If it is something you would love to see and other software engineering stuff, make sure you subscribe to this channel and hit the notification button so you can get alerted when the next video actually comes up, hopefully soon. See you on the next one, guys. Cheers.